Hello, Vamshi. Hey, how are you?
Hi Rahul, I'm doing good. How are you?
Doing good, Vamshi, in the morning. Yeah. Yeah, so before we start the interview, so can you give a brief intro about yourself and then we will proceed with the questions?
Yes, sure. So, hello everyone. I'm really glad to have this interview with Rahul for the channel. I'm currently doing my master's at NC State in computer science, and right now I'm interning with Amazon as an SDA intern. And previously, I worked with Rahul for 3 years at Samsung R&D. That's how I know him. So I'm really excited to see how the interview goes. Yeah.
Yeah, sure, Vamshi. So I have shared one Quarterpad link in the chat, so can you try accessing that if you have the permissions?
Um, yeah, can you send that again? I think
Okay.
this
Yeah,
got
yeah, sure, sure. Yeah, I just sent it.
yes, yes. I'm able to join. Should I share my screen for this?
Oh, yeah, yeah, please.
Can you see my screen?
Mm, yeah, I can. So let
Okay.
me also jump to that Coderpad link and I'll paste my question. You're on the link, right, currently?
I'm switching the tab. Yes.
Okay. So the first question is basically we are given a string and string something looks like suppose A, B, B, C, D, and each character in this string is denoting a particular color, right? So suppose A is denoting some color, B is denoting some color. All
Okay.
right, and we have to arrange this string, like we don't have to basically arrange, but we have to make this string in such a way that no two characters or no two colors are adjacent to each other. So there are two
Okay.
B's adjacent to each other, right? So we don't want them to be like this way. And we
Okay.
are also given one array, suppose array of size 336 in this case, and the elements would be 1, suppose 2, 4, 5 and 6 and 7.
Okay.
Yeah. So the this array denotes like what is the cost of removing this a from this string. So I can remove this a from this string with a cost of 1. I can remove this b at a cost of 2, right? So I can basically remove any of the characters with a particular cost associated with it,
Okay.
right? So finally I have to make this string in such a way that no two colors are adjacent to each other, so the string should somehow look like a b c d a. Got it, right?
Got
So
it.
I have to remove one of the b's in the string,
Okay.
right? And
Understood.
finally I have to do it in such a way that I have to do it in a minimum cost. So this is the cost that may occur when I remove a particular character. So if I remove a, it is done at a cost of 1. So in this, as you can
Mm-hmm.
see, right, we can remove either of these two b's, and the first
Right.
b can be removed at a cost of 2 and the second can be done at a 4. So minimum cost
Right.
should be 2. So I have to return this minimum cost,
Understood. Right.
right? So we don't have to actually convert the string and we don't have to return this. We have to just return the minimum cost.
Minimum cost associated. Okay.
Yeah.
So if I get the problem statement correct, so we'll be having a sequence of characters, and so whenever there are two consecutive characters of the same type, basically the same characters, if we have in our case, we'll have to modify the string such that you'll have only one. You have to remove one of such characters,
Yeah, correct.
and then yeah, and then you have to get the minimum, and each removal has a cost associated with it, and you'll have to remove such that you have the minimum cost at the end
Yes,
of it.
yes. Like ideally, you shouldn't modify the string, but because we
I
don't have to
understand.
return the string. Yeah. So keeping a
Okay.
count of the cost as well would suffice.
Okay. So yeah. All right. So if we have A, B, B, C, D. So So we have to iterate through the characters at least once. So just give me a moment to get to
Yeah,
to
take
come
your
with
time.
it.
Yeah, please.
Yeah. I'm just thinking if we need to maintain. Do we need to have a map or not, or if we can just maintain a previous character and work with it? I'm just
Okay.
trying to see if that works. So, previous. See which one is what, and then you move that there. Okay, what F3. Okay, I think we can just maybe consider 2 pointers. Basically, two pointers as in one which would keep track of the previously visited character, so that we can compare the current character.
Okay.
And whenever both of these are same, we would check with the array to see which one has less cost associated with it, and we'll maintain a global cost variable,
Yeah.
and we'll see which of these two characters has the least associated cost, and we'll update the global cost variable, and we'll iterate through the array accordingly.
Okay. So here you are assuming that we can have only two characters of same type, right? Like, what if we have three or four? Like,
Yeah. So we can have three. So we'll be considering the first two. As soon as we see that these two are same, we'll remove one of them, and then we move the pointers one by one step forward. And then again, you'll come across two similar characters, and then you'll have to remove one of those characters. So I think if we proceed forward, no matter how many repeated characters we have, I think this can handle that.
okay, sure. Looks good. Yeah. Can you try implementing it?
Okay. Yes. So I'll be coding in C++ itself for this one,
Okay, sure.
and I'm just move this, and I'm commenting out your question part,
Yeah.
and okay, I can.
You can write a function in which the input is string and a vector.
I'll do that.
Yeah.
I'm actually not sure of the imports, but yeah.
You can. Okay. Anyways, let's see if any error comes. Yeah.
Yeah. I'm just considering the current input as is for now.
Okay.
And with the development, we can consider another input and code execute it.
Okay. So you are sending in the min cost function as an array, but you are consuming a vector.
Yeah, I've seen the error. I thought I'll update that.
Okay.
I'm trying to get the
Uh-huh.
value and the logic correct first, and then we can go with the error setup.
Okay, sure, sure.
So if we are considering the minimum, we'll update if it is minimum. So we can consider a maximum value for this. For now, let's consider 1000. We can have it in max as well, I guess. Just to be. Okay. Two pointers, and we can have a base case actually if the length of the string is just 1. There's no cost associated, and we can return 0.
Okay.
I think
str dot length is there. Yes.
Yes. Okay. So now, now we can have two pointers and pref is equal to 0 and print is equal to 1. We can start with the first character and str of print equal to str of over here. We'll have to check with the cost array and see which one has which one has less cost. If than or equal to cost of previous, basically. If this is the case, if the current cost is more than the previous cost, we have to eliminate the previous character. Sorry, we have to eliminate the current character because it has less cost. Actually, we don't have to have it as something more. We just have to update it. So links and cost of previous. And once this is done, I'll have to move by one character. So, so previous becomes current and current. I don't need a for loop actually. Okay. So while we have the final character, okay. So I'll consider if I've considered the base case, I can also consider the string is an empty string. So even then we can return 0.
Okay.
Yeah, and then the minimum length is 2, I'm assuming. So we'll have to do this and then while str of current. If the current character is equal to the previous character, we have to consider 1 and then you have to remove 1. Interest is equal to cost of got less than or equal to, then yeah. Otherwise, I'll have okay. think this should work. I have to return this. Sorry.
Yeah. Yeah, just
Okay, this is what
okay.
for this test.
Okay, let's use some other test case. Can you write some other test case which is a bit complex one?
Okay. Okay, let's consider having multiple, maybe something like this.
Mm-hmm.
It will have more than two
Yeah.
repeated characters
Okay.
and multiple instances of it. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So this is 6. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So the answer for I'll just calculate what the answer should be. Sorry?
Yeah, I'm just seeing what is the expected answer in this case.
Yeah. So if for the first three
I think
A's,
4 should be
we'll
the
first
answer.
remove the first A, and then we remove the third A.
Yeah, 4
And
is the
then,
expected answer. Yeah. So we
Okay,
remove the
and
first
then-
and the third, and then 1 plus 1, 1 plus 1, 1
It
plus
should be
1.
4. Yeah,
Yeah.
should be 4.
Okay.
Yeah.
Okay. Looks good. Okay. I'm just looking at the other test case. Let me just see if we
Sure.
have. Can you check if all the characters are unique?
Okay. Yeah. Just have 5.
Yeah, looks
0.
good. Yeah, 0. Cool. Yeah, the solution looks fine. The time complexity here is
Time complexity would be we go off the length of the string.
okay.
So it's O of n if we have n as the length of the string,
Mhm.
and the space complexity is O of 1 because I'm just using two variables to store the current and the previous character. So it's often of 1 space complexity.
Okay, all right, got it. Yeah, this solution looks good. So let's jump on to the second problem. So yeah, you can comment the existing code that you have written
Okay.
for this.
Okay. Yeah.
So I will write from line number 45, basically 47. So in this problem, we are given a 2D matrix, and each index in the matrix is denoting some particular character, right? And also we are given an input word, like it's a string basically. So and from a particular index, if we are at in a matrix, we can move in all 4 directions, right? Top, down,
Okay.
left, and right. And we have to finally return true or false whether this word can be formed using the path that we can traverse in the matrix in these 4 directions.
Understood.
Yeah.
I'm just forming a matrix out of it so that I can visualize.
Yeah, let me also form it for you. 1 second.
Thank you.
Yeah, you should be able to visualize it now, I think.
Yes.
Yeah, so the
So
word
it's
is A, B, C, C, E, D. So we start from here, B, C, then we go down to this C, then this E, then this D. Right? So we have to
Okay.
return true in this case.
Understood. Okay. So since we are going all 4 directions and we are looking for a match, the first thing that comes to my mind is backtracking.
Mhm.
Because at a particular point, we check that character. If that is true, we'll So we have four options. We'll go for all the four directions, and if that is true, we proceed. Otherwise, we backtrack and then go to the next direction of that particular character, that particular position in the matrix. I mean,
Okay.
um, uh, this is so.
Okay. So if you are at a particular point, like somehow you have reached a particular point, do you have four possibilities or lesser number of possibilities?
It will be maximum four, because if you are at the topmost row or the
Okay.
bottom or the
Yeah.
bottommost row,
Mhm.
if you're the topmost row, we can't go top. And if you're at the first index, then you can't go left and top. So maximum directions we can go is four. At the same time, we also can't go back to the same character we came from.
Correct.
So we have to maintain a visited kind of a Boolean visited array, saying in that particular iteration, did we visit that in that particular path traversal? Did we visit that character before or not?
Okay.
Just give me a moment to formulate this in my mind.
Sure. Yeah.
Okay. Yeah, I think so. What I kind of explained should work. So we start from the top left quarter of the matrix, and we start from the first character in the string, and we match the corresponding elements. So first character of the string and the top left element in the matrix. We check if they are um, equal, if they match. If yes, then we move to the next character in the string, and we loop over all the directions possible from that element in the matrix.
Okay.
So before we proceed, we check if the move is a valid move or not. When I say valid, we check if the next character is already visited or not, and basically the constraints of the matrix are also met or not. If they are, then we move forward, and then we have the corresponding check.
Okay. So it's recursively you will be traversing the whole matrix, right?
Yeah. So once we reach the end of the string, it means that we did get to we could find the word in the matrix, and we can say that we can return true from the function.
Okay. So in this recursion, like, won't we be solving a particular problem again and again? Like, there will be overlapping problems or not?
Okay. E- I don't think we have overlapping problems because the order in which we get the characters in the string is important for us. Like for instance, if we have ABC and then D ABC, if we find ABC once, we can't say that we found ABC again after D. So what I'm thinking is my thought process is, if we have ABC, D, and ABC, if we find ABC first, then we come to a D. We can't assume that we have an ABC after this, as because we found an ABC before this.
Okay.
So I'm thinking an overlapping subproblem don't exist here.
Okay. Yeah. You can go ahead with the implementation if you are confident. Yeah.
Yeah, just a moment. I'll just think about that.
Sure.
Because, like you said, backtracking would involve a lot of recursive calls. Part of those recursive calls can be eliminated by using a visited array, and we can avoid an infinite loop. But Just thinking if we do have overlapping of problems. Okay. Yeah, I mean, I think we can. And as of now, I think we don't have an overlapping subproblem case here. So I'll be going forward with the backtracking approach.
All right.
So I'll just take this input. I'm not sure if the initialization is correct for this.
1 second. I had share the vector, right? So that should work.
Okay. Okay. Just directly with the square brackets.
Yeah, it should work.
Okay. Oh, it's a cat. Sorry.
Yes.
Or string double quote. Missing something here.
Cache should work actually. We will replace it with single quotes if not.
Okay. Fine. Yeah. So I'll just start with the function first. Let's initially have it as okay. We can have boolean. I need to have the same. Basically, I have to have a visited matrix of the same dimensions.
Hmm.
Name it visited. Initialize everything to fall. Oh, sorry. Um, so we initialize this.
You can directly assign visited equal to matrix.
Visited equal to matrix. Okay, I wanted to initialize everything to 0 to start with.
Oh, okay.
Yeah, so I'm just initializing a new one. Of calls. Understood. Sorry about that.
Yeah, no issues.
So I'll name this as z pointer as the one which we are using to traverse through the string.
Okay.
And we also need util function which would say if it's a valid move or not. So basically, next index actually instead of rows and columns, get rows and columns directly here. Each time we already got it, so yeah, I know. Okay. So now if I less than 0 and then I and R. If it's a valid index I and j, then we can check for the visited also. And we can return true, it's valid. Else they return false. This is checking the validity. Then let's start with the iteration. Okay. Then these things we can have here. Okay. And initial pointers would be equal to 0 and equal to 0. Mark the top left and right. String. We will call the find word function. Matrix. Visitor. J and PTR. It's taking a lot of
Yeah, it's okay.
and basically to have util function so that we can call it recursively.
Okay.
I'm sorry, you also need to pass the word also. We didn't define the word.
You're passing the ij in this from the main function.
To start with, so I'll start with 0 and 0, and so over here, this is basically I'll start with 0 0 and I'll check for the next one, and then I'll recursively call for the next method.
But find
Next
word
recursive.
will be called only once, right?
Find word. Okay, so I'll have to have another util. You're right. That util will be.
No, I mean
basically
like the
called.
find word function will be called only once, or it will be called recursively.
I'm planning to have it called recursively.
Okay.
So this will be the recursive call, and here I'll check if the pointer PTR is equal to the length of the string. If that is the case, then we have found the word.
Okay.
Otherwise, we have returned back. I'll just see if we can have another util function which will be called from find word.
Yeah, it's okay. No issues. Yeah.
Okay. Am I missing anything? Okay. Yeah. If PTR equal to not length, then basically we found the word.
Okay.
Else we check for the current character. Backtracking is always clumsy when it comes to the code. There are a lot of things to handle.
Yeah.
Okay. So this is the case. This is the case. Then we have to run a loop. So we have to consider. We also have to have the direction. So we have 4 directions possible. So we can go forward, which will be 0, 1. And go back, which will be 0, -1. We can go down, which will be 1, 0. And go up, which will be -1. So this is to keep track of the directions.
Mm-hmm.
And sorry about that. Okay. So I'll have to consider each direction. Since we got a match, I'll consider each possible direction going forward, and then I'll proceed with that path to which can lead to a potential match. If not, at that point, I'll have to backtrack and then
Yeah.
go to the next possible path. So I'll have to validate this first. Validate off. I have to pass a lot to this. And I and j are the same. No, I is a plus x of k. A plus y of k. Okay.
Why the rows and columns are vector? These are just integers only. Right?
Yeah, this was so I thought first they are x and y, so
Okay.
I want to change that, and then I realized it's basically
Yeah.
below that. My method definition itself is actually getting too big. Maybe I can declare them as static so that they're not going to change actually.
Uh-huh.
I can declare them global, I mean.
It's okay. We can do these things later.
Yeah. So got x and y, and then I got. Did I not pass r and c here? Oh my god. Okay. Then that's it. Before I do this, since I got a match, I'll have to mark the current one as visited. So ij equal to 1. And okay. Let's do one thing, we can calculate it on the fly over here instead of. Sorry about that, I just don't want the method to go even more,
Mm-hmm.
the definition to go even more big.
All right. Yeah.
Yeah. So I think you're missing something. IJ matrix visited. IJ. Okay. Actually, I don't need matrix for this. Why do I need matrix? They're of the same size anyway. You can use visited for that.
Correct.
Okay, so now if the current direction is valid, then I call that basically find word of matrix visited word. And since I'm calling it again, I think I'll have to okay. Okay. Then I'll have to pass pointer plus one because I'll have to check for the next character in the string.
Yeah.
I pass x and y. Okay. If it is valid, then yes. Otherwise, I go to the next one. So I'll have to return something. So yeah, this. If this returns true, then I can say that. Okay, sorry. So I'm calling the next one. What, for instance, let's assume I found a match. So this returns true. And that returns true. Okay, I think I have to catch the return that I get out of here to eventually calculate that. Just give me a moment.
Yes. Yes.
That's not true. Yes, so I get one. Next one. Right. Come here. Okay. Okay, I'm here. And just thinking way to return true for the recursive calls.
Mm-hmm.
Okay. And that is a match. So actually, so okay. Anyway, we have to once we are out. Basically, this means that this is not the right choice. So we'll have to make this unvisited. For the next iteration, we can use it. And okay. So actually, we can pass this. Okay, not exactly. Once we get to this point, I think it's false. That means we didn't find it in a way. I don't know if this makes sense. I'll have to go for a dry run only, then I can see if there's any bug over here.
Yeah.
So why is this causing an error? Because of that. Expected variable name, what is in the lambda capture?
Can you try running it? Let's see if it goes away or not.
Expected identifier before the token. Okay. Weird.
You can Google like how to initialize a 2D vector if you want.
Yeah. This looks okay to me actually. That's the point. I'm not able to understand. Or was it like this? No, right?
No, 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 no.
Let's just give it a try because I'm not sure. I mean, usually we get the input directly as a.
Right. No, no, this shouldn't be. Let me search and I will tell you.
So I'm sorry about that. I'm usually not.
Yeah, you
I
can
don't
focus on
usually use
the
that.
solution. I will let you know.
Okay.
Yeah, actually, it has to be curly braces instead of the square brackets at both the sides. I think.
Yeah, we tried that. I think it's basically the single quote.
Okay, let's see.
But I'm assuming because we have it's a character, and in C++, I think single quote says it's a character, and double would say it's a string. As far as I understand. Give it a try.
Mm-hmm.
And do you have any questions as far the approach goes? Do you think it's,
Yeah,
it's fine?
looks good. Like as you mentioned initially as well, like there are no overlapping subproblems in this. So
Yeah.
we can't maintain whatever string we have encountered. So recursion is the only way. But let's see if
Yes.
this works. Yeah.
Okay, I don't see there are any other compiler errors. Okay, I didn't return it, sorry.
Okay.
Let's see. It says 0. That means it did find it.
Okay. Let's try to debug it.
Okay. So let's consider in a simple case. Let's answer just AB.
Just comment this out and create a new one.
As in, okay, for the string.
Yes, string and the matrix. If you want to simplify it, matrix as well you can simplify.
Okay, it's going. It's giving me 0. And I think the problem would be the return over here. I'm calling it forward, but I think it's not reflecting it back. I think that's the problem. But
I
that's,
think
I'll
we
just
have
give
to, you have to, like, if it is returning true, right? So where are we returning true in this
over
method?
here. We check. We check if it's if the length is equal to
Yeah,
the.
yeah. Finally, suppose we have reached the end of the string. So in line number 50, so we are not returning whatever we have got, right? From the previous recursion, next recursion call, basically.
Right, right. Oh, yeah, yeah. Okay, I understand.
So,
So, yeah, basically, I think we can say return of all these four in a way.
or we can check if the find word function itself returns true, then we have to return true.
Yeah. Yeah, this makes sense. Yeah.
Yeah, let's try running it. Let's see. I'm not sure.
Yeah, you're right. You're right. Thank you.
Okay.
It's working for that.
Yeah, let's see for this.
Okay, it's working for this too.
Yeah, let me just ping you a couple of cases.
Okay.
I will just ping in the chat if you can copy those. So there are two
Okay.
examples in this.
All right.
Sorry if they have double quotes in them.
Yeah, that's fine. It's just that everyone has to wait who's watching this video for with me, with you.
Let me do it for the other part till then.
Okay. Thank you. I think if we pass it as string as well, since we're checking the entire string, it should work maybe.
Yeah, when I checked it,
No,
it
no.
worked.
In that case, we have to pass the word as a string of strings, I guess,
Okay.
because we are taking with character at that instance.
Mm-hmm. I could have done that in the notepad anyways. It's okay.
It's returning 0 for this, but you see that the output is true.
Yeah, you can debug
Okay.
it.
Yeah. Okay. SEE. So I think it's basically this way. S down and left. Right.
Try this as well. Yeah, so did it return true?
It returned false. Basically, it returned 0 for this. So I think there's an error for this one.
Okay.
And we test for the next one. So that we'll understand. Oh, these are
Oh,
mechanics. Sorry, everyone. I had to do this. You guys had to wait. Maybe there's some easy way which I don't know.
yeah, we should have test cases pre-ready. Yeah, it's fine. Yeah, we can quickly wrap this up after this. I guess time is already up.
I understand. Just basic, I think. There was some
Yeah,
error.
second last character E. Second last character E. Closing colon is remaining.
I
For
feel
second
like.
last E. Second last.
Oh, sorry.
Yeah. It should return false. Yeah, it is returning
That's
false.
right. Once.
Yeah, let's see once like why it is not returning true for the previous case.
Yeah. Okay. So debugging this would actually take some um, runs. I think we have to output few to see where we are going. So I think I'll give an output of to see at which index we are at right now.
Mhm.
Okay, it did not give me any output actually.
Oh, is it okay? So it is not going inside the validate condition at all.
I guess, yeah. Uh, yeah, pass 0 and 0, and everything is initialized to 0 when it comes to the visited matrix. So this is not true. It goes here. Uh, oh, right, yeah. Because only if it's a match, I'm going forward. Otherwise, I'm not even iterating it.
Okay.
So yeah, I understand. I'll have to. This one should be in a loop basically, since as we have to find the first character from which we can easily traverse down.
Correct. So if we are starting from the leftmost index in the matrix, then only it is giving output, right?
Then only it gives output because it knows that if it's a match. Basically, the first character is a match, then it's going forward. Otherwise, there's no call happening.
Correct, correct.
Yeah. Okay. I think we can go iteratively over here.
Mhm. You need to pass I1 and G1 right here in the find word.
Yes, yes.
Yeah. Okay.
There's some braces problem.
Yeah, you have used two braces. Go down, please.
Okay.
Line number 91, extra braces there.
It's giving 1 now.
Okay.
It's working fine for this input.
Yeah, please check for the previous cases. It might not be failing.
Yes. Yeah, that's true. I'll just do the one was working for. Yeah, it's not. It's giving the right output. 0.
All right. For the first
And
one,
yeah. This was the one, right?
mm, one.
Yeah, that's a match.
Yeah, looks good. Complexity wise, can you just tell me like what is the
Yes. So complexity wise, I think since we are going to worst case, we have to go to every character in the matrix.
mm-hmm.
So I think it's O of mn, where m is the number of rows and n is the number of columns. Since we have used, I think so. Yes. So I think it's O of mn when it comes to time complexity. And for space complexity as well, since we have used a visited matrix, it's O of mn there also.
Okay, space complexity is O of mn because we have used an extra matrix
Yes.
visited, but
Yes.
time
Yes.
complexity is it O of mn because we are traversing every character and in the worst case one by one, and if we are at a
Yeah.
particular character, we might need to traverse the whole matrix again, not whole, like we need to go to a certain path, right? So that would also come into picture, correct?
As in repetitively, you mean we have to go to the same path again?
Yeah, we might be because when we have covered a complete path and we are not able to find that answer that we want, so we are again invalidating the visited array. So it's not that we won't be able to visit the particular index again and again.
Right. 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 Okay. So
So just think like if you are at a particular index and you have reached that particular index from a particular direction, right? So now
right.
you have how many possibilities to go? So
From that point, yeah. So at worst case, I'll have to go through all the 4 directions
but you
till
would
that
already
till
be coming from a particular path, right? So that path you won't, no, don't need to consider again.
right. Right.
So four paths are the maximum if you are at a particular point, but you are already coming from a path.
One
So
path. Yes.
yeah, so remaining paths are three, right?
3 path. Right. Right. Okay. So you mean 3 times m and n?
Yeah, like little modification on top of that, but yeah, we can skip that if yeah,
Okay.
yeah, we
I
can give it
understand.
a
I
thought.
think
Hmm.
I think I missed the time complexity, I guess. Yeah.
Yeah. No issues. Yeah, should be fine.
Okay.
All right, yeah, these were the couple of questions, and we have completed them in an hour. So yeah, that's pretty good. I guess we can wrap it up this then, Ramshi.
Okay. All right then.
Thank you. Take care.
Thank you so much, Rahul.
Yeah, bye
Thank you.
bye.
Bye bye.